Hi, this is Larry. Today, the topic is Introduction to Database Design. We'll be focusing only on relational database design. Database design is an abstract concept. And what we're going to be doing is actually focusing on data to be stored. The data that is in storage that is then retrieved and updated. In object-oriented programming, it's all about the data, correct? Basically, it's about what data needs to come in, how it's to be processed, and where it's going to go out. What we want to talk about is where it's going out to, where it's going to be stored, and how it's going to be stored. And additionally, then how we're going to retrieve it when we want to put it back in. And it's basically, it's retrieving it where we put it back in when it goes out. Basically, how do we update the database? And to do this, we're going to use data modeling. Modeling is an abstract concept to be able to let us to be able to rationalize and to see how all the components work together. Very difficult to see things unless you can model it in some manner or form. And we're going to talk about logical and physical databases. There's a difference between the two. Logical is logical and physical is physical. We'll talk about that in a little bit. You're probably wondering, why are we doing design? Well, basically why we're doing design is that we want to reduce data redundancy. Instead of having a lot of different data in a lot of different places, we want to reduce that. We won't eliminate it 100%, but we'll greatly reduce it. We also want to develop entity integrity, meaning that we want to make sure that the data is associated with the correct data and that the integrity of it is maintained. We do want to make sure the data and the entity itself is maintained. Ease of maintaining, modifying, retrieving then becomes the next step. How are we able to go out there and maintain the data? How do we go able to modify it? How can we retrieve it? Those are components of a good database design. And lastly, the foundation for a physical database. You can't just go out and build a table in a relational database. You can go do that, but will it work? Will it reduce data redundancy? Will it help to provide for entity integrity? Is it easy to maintain, modify, and retrieve? It all comes down to design before you even start. So a good design does three things. Supports the business requirements, meaning that what data is needed for the business? Is it efficient? Meaning is it easy to maintain, modify, and retrieve? And is it flexible? Meaning as the company grows, can you easily modify the whole structure and add to it or delete from it without having to make major changes? So when you design, it all comes down to the roots. There are two different types of processes involved with database design. You have a top-down process and you have a bottom-up process, meaning that the top-down means starts at like the 50,000 foot level and you go down to the bottom. The bottom means you start at the bottom and you move all the way up to the 50,000 foot level. As we see here, the top-down model starts with understanding the business requirements. Understand the business or system requirements, meaning that you need to develop from the business, going around asking users what data do they need and why do they use it and what are the rules? What are the rules for handling data? From that, you're going to create a logical model, meaning that from the 50,000 foot level, you create a logical model. And that logical model in this case is going to be what's called an entity relationship diagram, an ER diagram. Entity relationship diagram. And that diagram will show you the different entities and the relationships with each other, and then structure it from there. The next thing you would want to do is take that model and within each entity, then normalize each entity. And looking at the entity itself, looking at all the attributes inside of it and making sure that they're all properly aligned with the correct entities, or if new entities need to be developed. Lastly, we're going to build a physical model, meaning that then we're going to go in and actually create SQL statements to put them and create tables, create a database, create a table. That's the last step. That's a top-down approach. So what would be the bottom-up approach? The bottom-up approach means that you already have existing files, forms, reports, or a database, and already have a list of business requirements. For instance, it's not uncommon today that a lot of programmers are forced into creating databases or adding things to databases because all of a sudden they have these other forms or reports or things that need to be done, and you already have all that information in paper or some other kind of model, maybe in an Excel spreadsheet someplace. And therefore you need to be able to take that data and you need to somehow think about all the other aspects of the business and how does this fit in to the database that you already have or you need to create. Then therefore what you do is from the bottom you start normalizing first. And normalization is a process we'll be talking about, but normalization is a process by which you take existing data that you know and try to put them in a logical format so that all the entities are good. All the attributes in the entities are related to each other. And then lastly, we're going to take and logically model it. So we'll go to normalize, and then we go back to the ER diagram. Remember, this is bottom up. We'll go to the ER diagram. One of the problems with normalization is that normalization only looks at the data. Whereas a logical model will be looking at the business requirements. So we take the normalized data, look at the business requirements, and we kind of loop through this a little bit to making sure that it goes back and forth and it's correct. Then we build the physical model. Then we create the tables in SQL. That is when we finally go and implement it. So what are requirements? You're probably asking that big question, what are requirements? Well, basically, whatever it is required to support the business. The kind of the structure and relationships of the business policies. The policies you have, the practices that are in place, and then because of those practices and policies, information that govern the operation of the business. What do you need to store for that business and operation, or for any organization, for anything that you do? What is it required to support the business? Methods for collecting requirements. Basically, you can do a textual analysis, review the existing documentation of set of rules and requirements. Then you can do structured interviews with people, users, etc., experts, people that are going to be involved with this data that's going to be stored. And lastly, you're going to do an unobtrusive discovery. Look at existing models, documentation, and applications. Keep in mind that business requirements are at the heart and core of why a database is being put together. It's because you want to store data for the organization. Whether it's a business, a nonprofit, you need to be able to have an understanding of what information is data is needed to derive the information they need to run effectively the business. Here's an example of some business requirements that might be from an employee database. Let's look at the first one. For each employee, the following information must be stored. Must have their name, employee type, skills, and department. What do these look like? These look like the name, employee type, skills, and department are attributes of what? Probably an employee entity. And then also it says the name, birth date, and gender of each of the employee's children must be kept. Oh, it must be another entity. Name, birth date, and gender. So it must be employees' children or dependents. Each employee must be assigned an employee type, and each employee can type apply to more than one employee. What does that mean? That's talking about the association between different entities. What I'm trying to show you here is basically it's not as simple as somebody coming up to you, build me a database and here's the attributes. Here's what the data that I want into it. It's not going to be that simple. People will not come to you and tell you, build the database this way, and you go out and create your SQL statements. They're going to come to you and talk about stuff in general, and you're going to have to glean from what they're talking about, what basically the attributes may be, exactly what data needs to be stored, what are the associations, what are the entities, what are the attributes, what are the associations between all that. It is not easy. Because keep in mind that a good design supports the requirements of the business, the organization. It is efficient and it is flexible. And it all starts with asking what the users want.